Point process and renewal process is a subject of this video. So we have talked about point processes. So if you have a collection of points on a line, like Poisson point process is called point process. It could be 2D, for instance, the location of mobile users in communication network, or location of hospitals in Ontario. So it's 2D Poisson point process, or the location of stars in space. They are point process, provided that they assume that they are tiny compared with, or the location of trucks. So point and renewal processes are interrelated. Suppose that you have a collection of points, and let's say the first one is T1, second one T2, etc. So we call these point process. So the sequence Tn is called point process. It's a set of random points on the time axis. Now, renewal process is the difference between them. So this is going to be Z1, the renewal process. So the first renew sample, and then you are going to have the time difference between these two. So Z2 is equal to T2 minus T1, and Zn is the difference between two. So the renewal process is another sequence random variable which is obtained by differentiation of the previous sequence. So obviously, if you know Ti, you can calculate Zn, or if you know Tn, and vice versa. Because the first Z1, T1 is equal to Z1, and T2 is equal to Z1 plus Z2, and Tn is equal to Z1 plus Z2 plus Zn. So by integrating the renewal process, you get a point process back. So point process and renewal process, they are interrelated using and then the number of points at a given time. So this is a stochastic continuous time stochastic process, which represent x of t. So x of t is the number of points. For example, for a Poisson point process, x of t is the number of points ti in the interval of t. So x of t is the index of I, which is the largest, which falls in the interval of 0 to t.